Uh, Thank you very much for that incredible talk. We have a couple, a bunch of questions have been showing up on the sheet. I'm going to grab a couple of these. Let's see. One relates to something you were just saying at the end there. How do you identify what seeds pre-building you should offer to help students with without over-constraining the outcomes? So it's pretty much your last point, but a pretty important one.
Good question. So interestingly, there were two ways, I think, in this case. So I gave a cube, right, in this in this, let's say, the tool. So it's super constraining if you look at that, right? So you can go with a crazy shape, but at the same time, I think it's super abstract because this cube is a very simple and abstract shape. It's generous enough for them to switch to anything afterwards, right? So that's the base template. We are talking about the template. The technique is a weird thing, right? So we discussed with Liz too. When you're picking a tool for the class, in my ideal scenario, I would also not pick a tool, not pick a software for the class, right? So I would say, okay, bring whatever you want, and we're gonna do this. So to keep that super open, in the past I was teaching scripting directly, right? So I was like, okay, the utmost freedom comes with programming. We're gonna open the programming interface. We're gonna start typing. You're gonna learn scripting or coding a little bit, and we're gonna make forms. So then I figured this cannot be a 1 semester class. That should be a 4 semester class for the students to get to a point in which, let's say, they're fluent enough. So long story short, you have to pick a tool, and within that tool, if you have more than one, just not be lazy, I would say, and discover all these tools, and then implement very kind of like make some small samples for them to use, and just let them go from there, right? So it is in a way still constraining, if you want to say everything is constraining, right? So this is constraining too, because we picked the problem already and we picked a platform, and there's probably a couple of ways of doing it in that platform, but the way you teach is very important. So this is okay. So now I caught your question really. You don't teach the technique. You teach the technique, but you say that the technique, it doesn't matter. The technique matters for just doing it, but there are other ways of doing this thing. The problem is what you create. Like the problem is the qualities that you generate, right? So, and I think that's the generous part. So in that respect, if you're able to give this understanding, the technique and the tool become secondary, which is fine. Because no tool is, superior in the sense that it creates a greater meaning or value or quality. I hope this answers your question.
That's really helpful. I pinned some of your thoughts down there. Feel free to improve them.
Yes.
So looks like, how about the fourth question on there might be pertinent to a lot of folks here. So you showed some incredible visual pieces that were in your class that originally might have had access to actually fabricating stuff, but you didn't. What are some thoughts for some of the educators here who are faced with, they're used to using output from Digifab and 3D printing. So are they now faced with helping the students like really master rendering, which is another topic, speaking of 4 semesters of study? What are your suggestions to help them work with visual ways to represent those geometries when they're used to just making meshes and paths and running to a machine?
Sure, that's a great question, because I love visualization. I spent quite a bit of time, still spending, and somebody mentioned VRay, and like I don't want to call too many names of tools, but I've been using VRay for such a long time, and I think it's a great tool. The problem with it is I considered teaching it, but then I really changed my mind, because the problem is if you don't know what you're doing with it, it's going to hurt more than it helps, or they need more time to, you know, learn the technique, right? So now we're back to technique, like Renaissance idea of we have to learn the technique to make something good. So I'm kind of like slightly, you know, shifting gears back here. The nice thing now is a lot of tools, software platform, now they have almost one-click button solutions. And the one we were using, as a matter of fact, you know, they changed gears and they put some of these shading styles, which are very convincing. And it's one click, literally. So by doing that, I think it just worked. So that's a short answer. And the long answer is, if you don't have access to that, I think there's always a chance to look for educational licenses of these rendering engines. Or if you are really in trouble, you can use the trial, you know, period for, this is not a direct advice, but, you know, I'm just kind of like thinking loud. You can use these things. But one thing that's changing is ray tracing. The GPUs are much, graphic processing units, video cards are much faster now. And even on your laptops, you can get some decent, let's say, ray traced images just out of the box, depending on the platform that you're using. And
that was really helpful.
Yeah, in my case, I mean, again, sorry, I cut you off, but I could have taught VRay, but I didn't have time. I already had to remove a lot of material from the class. It depends on you. Yeah. So
that makes a lot of sense. So by the way, I want to encourage, you know, all of those who are gathered here. We had some, you know, questions here when we got started with the question and answer period. But if you want to drop things in here quickly, want to make sure that you're not missing a chance to ask a question, you can also drop it in the chat. I just want to make sure everybody gets to participate. Let's grab another one. Okay, so the second one is asking about some open source repositories. If you want to take a quick look, you may be familiar with those two repositories. Open source ecology, and I'm not familiar with engineering world health.
No.
Oh, I should check this out.
Interesting.
It's question 2. These are repositories of parts and machine designs.
Yes.
As opposed, yeah.
Yes. No. This is good. I think this is not directly my subject, but I think it's useful in the way that I'm giving an example. You know, my analogy of an engine is closer to this example here, right? So and you know, we also, like in the past, I also, you know, happened to design like kinetic facades with a mechanical engineer and so on and so forth. So maybe I can answer this question and the third question together, right? So
perfect.
The third question is asking the teaching engineering and industrial design students the difference from teaching architecture students. So for 2, not really. I mean, you know, it's asking, have I done anything similar to that? Not really, but I designed on, I worked on skyscrapers, right? So it's pretty interesting phenomena in the way that a skyscraper is put together in a weird way. And even actually one of the projects that I worked on was a computationally designed, you know, complex parametric facade, which was under construction, but the data was wrong, right? So it came back to me, and this is pre-generative design software era. It came back to me, so I just had a point cloud and a dummy file, no scripting and so on, no smart, you know, no parametric, let's say, model. So I had to parse each and every point in space and discover the connections between them to figure out the curtain walls, panels, and, you know, regenerate that data with the brackets and so on, and how this thing can put together. So I think my whole understanding is coming from there, you know, going from this like one screw of the one bracket of the one panel of the curtain wall, which makes a half a kilometer tall building, is a pretty interesting situation. And now just shifting to industrial design products. And beyond shoes, I also happen to design small gadgets or make installations, you know, which are, let's say, mid-size, right? Not a building, but not a product either. But anyway, I would like to look into the machines too. So mechanical design, mechanical parts would be the area that I'm least experienced in, right? So that's not my really specialty. So, but thanks for pointing out to the links. And so I was lucky, like whenever I met an engineering design student, they were fascinated and they were more interested in the theory and the books and the readings, you know, and the design understanding, because I also work on daily basis with the engineers, you know, at New Balance. And it's interesting because I learned a lot from them, and I think they see a lot from us. But at the same time, there's definitely a different, you know, like a design understanding. You know, when you say you use the word design for these engineers, they have a totally different understanding than at least what I understand from design, right? So definitely have some changes, but I benefited from it. And in the workshop that I mentioned, I had a mechanical engineering student and who came in, and when he left the class, I think it was an opportunity or opening for him to utilize his system design or mechanical design understanding with more input or with a wider opening about aesthetics and design. So when he was out, he was like, okay, I'm going to make a, you know, design portfolio out of that, which was super interesting. So industrial design is interesting. I don't, in a way, because of my education, I mean, I spent so much time among them. I learned a lot from them. I feel very close, like maybe not as an architect, maybe personally, I feel very close to them. And I don't think they're like too distinct with, of course, in architecture, you know, you have like space and scale is different and so on, but design thinking, design process is somehow, I would say, pretty close enough.
Great. Very helpful. Okay, let's see. Next question in this. Okay, first question. Do you have some suggestions for ways for us to introduce computational designer as a route that might interest students excited about math and patterns? How do you help them understand computational creativity? I remember you were talking about computational creativity. I think in general, you know, students, like computational design is pretty advanced and people see it and they're like, oh, there's something happening there. But if you have suggestions for ways to really express to those who haven't yet played with the tools or really explored scripting computational creativity.
Sure, that's perfect. So I got a call, I mean, I got an email from Cox Architecture in Australia 2 weeks ago, and they wanted me to give a lecture over LinkedIn, and the title was Computation and Creativity, right? And they suggested to call it computational creativity, and I said, okay, let's use computation and creativity instead of computational creativity. And that became the title of the presentation. This is an amazing question for that reason. So one resource, I have a couple of lectures, again, recorded on YouTube. I'm just giving you this because we have a limited time. And what I do is, I 100% agree. I think one word that you used here in the question, pattern, making patterns, is very, very important. So, you know, computational design, generative design, parametric design, I think people ended up producing a lot of noise, as well as, you know, finding great solutions and making amazing designs within the last couple of decades, right? So what I do is I try to explain computation as a way of putting parts together, right? So start with a square, put another square next to it and rotate it and something new emerges, right? But I try to make it clear that you are the one who is creative. When I put two squares together and overlap them and a new shape emerges, I mean, you can try to write an algorithm that detects the new shape, but detecting a new shape is not our experience, our perceptive experience of seeing the thing. So that's a very primary thing that we need to teach the students, right? So computation and creativity, right? So it is a way of combining these two things. Hey, I'm going to be a master. First, I'm going to learn how to make patterns. Then I would like to, you know, see how I can use mathematical equations or, you know, simple equations, sophisticated equations to generate, you know, patterns in 2D, patterns in 3D. And then, you know, you're going to reach a, let's say, level that you would see that, okay, this is all patterns. What am I seeing in this? What can I do with this? Why pattern A is different than B? is it only because it's functioning well, performing well, or is it that it just looks beautiful? You know, this kind of discussion is very important. And again, if you go back to this, you know, the what I shared today, that's exactly the discussion, right? So I teach the technique, but I'm saying that, okay, computers help you make patterns, but we are the ones who are seeing those patterns, and we have to go like one click beyond that, right? One click above that. So teaching that gap is the most challenging. I think it's the, you know, the tip of the pyramid in that respect. And sure, and I think just you can always use these you know, very interesting shapes and, you know, like patterns and so on to lure the students into that. But again, like this computational designer thing is somehow still new. It's been a while, although, yeah, I think it needs to go like hand in hand. Let's do the technique, but at the same time, you know, this is just a way of doing things. Otherwise, we need to look, be still critical about what we do. Yeah.
Oh, that's really helpful. And I think we grabbed some of these details you were saying, and also added your YouTube channel to the resources, so people can go check that out. So I have a selfish question of my own. I mean, you're particularly with solving some of the problems at Reebok and you know, replacing, you know, foams and some of these you know, lattices that you're working on. Do you have suggestions for, like, these lattices show up in 3D printing a lot, generated in various ways to serve an aesthetic purpose, which is often, you know, like various like uses of like Voronoi, you know, patterns and stuff. You know, so you're like showing, oh, it's additive because we've done a pattern to it. But do you have suggestions from your, you know, battle-tested ways of using this functionally, that educators can get, you know, find some ways to help students understand how to build these kind of patterns or foams, or you know, build, you know, cellular approaches to this. What are some resources that have been helpful to you to help kind of onboard people into this way of thinking, to kind of get them beyond the, you know, oh, I'm making something that looks crazy, so it must be cool, and over to the, oh, I'm serving a functional need, and it's this is real opportunity.
Sure, yeah. I think it goes both ways. So very quickly, the premise of parametric design, I'll take things from there because it suggests, you know, like a change in flux, right? So everything is kind of like merged. And that happened in architecture, right? So we moved from window to panels changing shapes, which was happening on the surface, right? So, and that indicated, okay, the second question was, how can we use this for aesthetic purposes on a building to make it look different? Or how can we, you know, functionally adjust, let's say, the panel sizes and, you know, to control, let's say, the light that's entering the building, solar insulation, and so on and so forth. So the same thing goes, just take this idea in 2D from the building facades and move it to a 3D volumetric design space. So what happens there is that there are certain functions and considerations that you can address by using the idea of flux, right? So I showed that with the heel part that I showed you. So in the past, this New Balance end cap technology, the heel part, you know, you have like nested parts, let's say, which is under the heel, it's giving you support and cushioning. On the medial side of the shoe, it's kind of helping you, you know, remain stable, so it's supporting you and so on and so forth. And these are different materials. One is foam, the other one is TPU, the other one is this and that. So what's happening with editor is that those functions remain, right? Or the needs remain, but the way you execute it is not making these different parts and nesting them. Now it's creating the right way to generate that flux across a volumetric space, right? So that's the notion. Oh, then that brings that you don't have a part which is defined by, you know, a boundary shape, which is B-rep, by the way, in, you know, like computational terms. You deal with the boundary shape, but what happens is the border is not a surface anymore. The border is maybe a zone, a range, right? So you start modeling implicitly and so on and so forth. So, and that works for both, right? So if you are reaching a surface, the boundary of the, let's say, the product in which you see the shapes and parts, you can adjust it to look in whatever way you want it to look. And on the internals, if you're trying to use a specific lattice, you mentioned Voronoi, for instance, that you can adjust that to, let's say, fulfill a functional need. That, let's say, I need more support. In the previous example, what we can say is under the heel, you would make cells larger and the struts thinner, so it becomes softer in the middle, right? So you sink in, so it's not like hurting you. Whereas on the medial side, you would need to, let's say, thicken the struts and, you know, use more material, smaller cells to create this support thing. And the idea again here in generative design is that this happens in a flux, right? So you don't have to cut something and glue the other thing and next to the other part. And the machine doesn't, because the machine doesn't care about what it's as long as it can print. You can print all these things differently. Just a little addition to all this story, your question and what I answered is, moving forward, this is going to be customized, right? So because we all have different bodies, different shapes, and we all walk with different gaits and types. So all this will be addressed and you know, first understood, then addressed by making these products.
Oh, really helpful. Let's see. And so just, I have one last question. Oh, okay. Would you like to share a little bit about what your experiences are working at New Balance while teaching are as a final question? Then I think we've probably run out of time after that one.
So, I mean, I can, yes. So the environment is super supportive. What we do is we try to influence, you know, people, the next generation. And again, you know, by doing what we learn from them. And it's bi-directional again. And I think we are one of the, let's say, New Balance is one of the companies that I, you know, observed in this field, in the area, which is very open in that respect. So also before I joined New Balance, before 4 years ago, you know, like 5-6 years ago, New Balance was already had a partnership program with MIT Media Lab for I think 2 years. We worked with nervous system. We still work with nervous system. You know, who were instructors at MIT and who also helped in, you know, developing a couple of products with New Balance. And also they are, you know, MIT spin-off. So it's pretty good. It's very positive.
Fantastic. So thank you very much for sharing. This was a really valuable set of resources, and thank you everybody for attending and sharing your questions. Onur, I recommend you take a look and make sure to improve our little, you know, our quick notes as we were trying to copy down some, you know, feedback from what you were saying, and we will share back these resources with those who attended. So thank you again very much, and we look forward to now watching all your YouTube videos and seeing some of your further lectures on these.
Thank you.
Yeah, thank you.
Yeah, thanks again for the invite, and please, you know, get in touch if you found any of the ideas interesting. LinkedIn, I'm pretty responsive, and I would like to hear the people who listen to me too. This always happens, but I want some feedback too. So thanks again. Thank you very much.
Thank you. Appreciate
Thank you so much.